quick recap of quadrilaterals as we had seeded. Okay, just a recap of quadrilaterals as you've seen them, and we're going to be looking at proofs. And remember that wonderful word that we had learned before, corresponding properties of congruent triangles are congruent. I think we have already done this one. We've already proved this one. Did I put the wrong one in here? Because this class had already done this one. Where's the other one? Here it is. Okay. Yeah, I'm trying to get here. All right. All right, so we're going to be looking at this over here. Alicia's like, what the heck is this? Don't stress. Okay, we're going to be looking at this one. It says, we're given that angle 1, the one that is named 1, angle 1 is equal to angle 2, which is equal to angle 3, which is equal to angle 4. And then they want us to prove that the quadrilateral STAR is a rhombus. It's a rhombus. Okay, so we're going to have to look into what's going on here. And Alicia's already just like, hi, ma'am, make this make sense, ma'am. What is happening here? Relax, guys. It's not that bad. I promise. It's not that deep. Okay. Okay, so we first need to think, guys. Let's think of all the properties of quadrilateral, or of a rhombus that we want to know here. Okay. What properties can we possibly use by looking at this that is going to help us? What properties of rhombuses, rhombi? I don't know. What properties of a rhombus do we know? Anybody got anything? Sange, yes. We know for a fact that it's going to have 4 sides. It's definitely going to have 4 sides. But what do we know about a rhombus specifically? Novella's like, okay, good. 2 pairs of, what about the opposite angles though? What about the opposite angles, Tandikolo? Yes, Tiana. Yes, Mira, you're 100% correct. It's not a rectangle. What do we know?
The opposite angles are equal.
Good. So this angle must be equal to this angle. Anything else?
Yo, I don't know, man. I checked the when I checked, they're saying diagonals bisect.
Yes, the diagonals bisect. Yes. So this diagonal and this diagonal must meet in the middle. Right. But what do we know specifically about this angle where they meet in the middle? What must it be?
Is it a midpoint? The E? Are we talking about the E?
E is a midpoint, but they haven't told us that. They haven't told us that E is a midpoint, so we can't just assume. We can't just assume that it's a midpoint. Okay, but we do know that when they meet, when the diagonals bisect, something must happen with this angle over here. It must be equal to something.
I think 90 degrees.
Yes, absolutely, 90 degrees. So if we can prove that these triangles, when they meet here in the middle, they meet at 90 degrees, then we can prove that it's a rhombus. You agree with me?
So little. I'm not sure.
Okay, we're not completely done. Good. They bisect each other and meet at 90 degrees. What do we know about the sides? Somebody already said that all the sides must be equal. Because it's a rhombus, all the sides must be equal. Bushale says adjacent angles must be supplementary. Absolutely. That's why T over here must be equal to R. And that's something that we're going to have to prove. Okay, let's have a look, guys. What is it that we can look at over here that's going to help us to prove this? Just from the information they've given us. Just from the information they've given us, guys, we want to make sure that we're getting the right things out of this, because all of this stuff that I've written on here, that's what we need to prove in order to make this a rhombus. Okay. Shimome says opposite sides are parallel, and that's something we need to leverage today. Okay. Oh, close, thank goodness. Okay. All right. So let's look at the idea that if I gave you guys 2 parallel lines like this, and then I draw a transversal line like that, and I said that this line is parallel to this line, and I named this line BC, and I named this DE, and I named this F, and I named this G. I'm going to name this 1, 1, 2, 2, 3, 3. What do we know? Just by looking at what I've given you guys, what do we know? Let me draw that a little bit better. There we go. What do we know? If BC is parallel to DE, what other two angles are we going to be looking at? Yes, that's a tankolo. We're going to be looking at fun. We can look at our alternate angles, right? So we know that if I look at the Z or the N in fun, that G1 needs to be equal to F1, right? Which other two angles can be equal to each other? Yes, Pablo.
I think that's a C, ma'am.
But let's just see over here.
Ma'am, the one that's next to the F.
Next to the F. This one here.
Yes.
Okay, good. That's also going to be equal to F1, and this one over here, we agree. They're both going to be equal.
Yes, ma'am.
Good. Give me two other angles that are going to be equal to each other.
C2 and G1.
Okay, it's going to be F2, this one over here, F2 and
G1.
Ooh, G1 is this one on the inside. No, they can't be equal.
Ma'am.
Which other one? Look at where it is. It's on the outside, so which other one must be equal to it? Have a look in the chat. Everybody's helping.
Oh, G1, G3. So
No. It's G2, my guys. This one over here, it's G2. They must be equal.
Oh, yes, ma'am.
Okay, they must be equal. All right, so we need to make sure that they are working together because the Z is in the other direction in this one. Okay, or the N. So when we look at G2 and F2, the Z is moving in this direction, like that. Okay. Alicia's laughing at me. All right, so what I'm getting at here, guys, is let's say, for instance, I just give you two lines. If I just give you two lines, and then I draw transversal, Pablo, I need you to just mute for me, please, my boy. Okay, if I give you guys these two lines and I tell you guys that this angle over here, this angle 1 over here is equal to this angle over here. And then I say that this angle over here is equal to this angle over here. Because they have a transverse line going right between them, what can we then conclude about this line and this line? What can we conclude? That they are? I see if you guys had watched Teacher Nels, she gave you guys the answer. I saw it come out of her mouth. Yes, that's it. Good. So we can conclude that if the opposite angles to each other are equal, then the lines are parallel. Okay. And because we normally work forward, where we would say that the lines are parallel, therefore the angles are equal, we are now working backwards. We're saying that the angles are equal, therefore the lines are parallel. What we call that is a converse, not the sneaker, okay? Converse, okay? And then we say angles equal in parallel lines, okay? Angles equal in parallel lines. I'm pretty sure I'm saying this wrong. I know I'm saying it wrong. It's not supposed to sound like this. It's supposed to say angles in parallel lines equal to each other, or alternate angles in parallel. Oh, teacher Nels, help me out here. I've forgotten how it's supposed to sound. But it's supposed to sound something like this, guys. I need to find it before we continue. All right. Okay, so now if we think about this, guys, if we think about it, I'm going to find what it's actually supposed to look like. I've given you a line here, and I've given you a line here. Okay, and then in between these two lines, I've given you a transverse line. Okay, Liabona is on point because the information they've given us, they've told us is what it is. It is what it is. They say to us in between here, we need to look at not T1, which two of them are actually, Liabona, you're not wrong, but it's in the opposite direction. Which two angles are actually supposed to be equal to each other here? The ones on the inside of the Z. So it's going to be that one and good. That's a Tiana. T2 and R3. So we can conclude that T2 is equal to R3. But that's information they've given us. They've given us that information, right? They've given us that information. And then we can look at the fact that I've given you this line and this line and a line that goes between them. Sorry, don't do that again, teacher Coco. Wait, let me just make sure I'm not talking the wrong thing. Good, okay, I've done it correctly. Right, so I can then say T1 and R4 are equal. All of this information has been given to us, guys. It's been given. And then I can say T1 is equal to R4. They've given me all of this information. Here it is, R4. This is also given information. Now, because they've told us that these two angles are equal to each other, then we can say which two lines are parallel. Yes, yes, we should, Alicia. Oh, hello, Jasmine. Okay, let's change your name for you. We will, hello, Jasmine. Give us a second, my sweetie. Okay. All right. Okay, Jasmine, I'm gonna look at me writing your name on the screen instead of your actual name. All right, so if we can prove, guys, if we can look at this, okay, if we can look at this and say that this line and this line are parallel, or these two angles are equal to each other, which two sides can we say are converse parallel to each other? Snakonke is asking, what grade is this? This is grade 10, my sweetie. This is grade 10. Yes, Tiana.
Ma'am, TA is going to be parallel to SR.
Good. TA is going to be parallel to SR. And the reason is because of the converse parallel lines. I'm going to find out what it's called in just a bit. Okay. Which other two lines are going to be equal, are going to be parallel to each other?
And then TS is parallel to AR.
Beautiful. TS is parallel to AR because of the converse parallel rule. Okay, I'm going to find it. I just forget what it's called. Converse parallel lines. Okay, don't quote me on that. Thank you, Tiana. That was excellent. Good. So we can use the idea that the angles in between two lines and a transverse line are equal. That means that the sides will be parallel to each other. Jasmine, there are two of you. I don't know which one to unmute. Okay. Hello. Okay, that tells me that these are parallel and these two lines are parallel. Okay. Hi, Jasmine. Are you there? Okay, she's gone. Oh, no. All right. Okay, so what else can we possibly do, guys? We've used the converse parallel rule to look at the fact that these two are parallel. What else can we prove is possibly equal when we use this rule? Hi, Jasmine.
Hi, sorry for this. It came late to class because of a connection issue, and then the website was saying it's unresponsive for Watobe.
Is it?
Yes.
Okay.
And I got a question.
Yes.
Can you still hear me clearly though?
Yes, I can.
What is the formula for midpoint?
We're literally going to do that in the next 5 minutes. Okay.
Oh, so I didn't miss out anything.
Oh, wait. Okay, are you talking analytical geometry?
Yeah.
Okay, stay on till the end and I will show you, because at the moment we're still busy with Euclidean. We only start the midpoint next week, Monday. Okay. But stay on the line afterwards and I'll help you. Okay.
Thank you.
Okay. All right. Good. Ethan is asking, what about SA and TR? Well, we can't say anything about SA and TR because they haven't told us anything. Okay. They haven't told us anything. Now, what we need to do, thank you, Teacher Nels, for that. Thank you. I just can't answer that question at the moment. Okay, what we're going to need to do, guys, is we're going to have to be clever about this. Because we want to prove that this is a rhombus, we're going to have to start using that funny rule that we learned. That cpctc is going to need to come into play here. All right, which means I'm going to need what? What am I going to need in order to make that happen? Oh, is it offensive? Sorry, we just had Ethan that was also called Zoom user. Offensive, we were going to change your name for you just now, my sweetie. All right. So do you guys agree that I can take the triangle ATR? Which other triangle do I then need, guys? If I use ATR, if I say in triangle, remember the order in which I moved, guys. Remember the order in which I moved. So if I go in triangle ATR, remember I started here and I moved to the left, I moved sideways and then down and then up. Okay, so I must move sideways and then down and then up, or in this case, sideways and then up and then down, which means I must map it here. I must go sideways. This is the only way that I can go. That's sideways and then up and then down. Okay, so that means triangle, that's a Chimamwe, and triangle SRT. Good. Triangle SRT. So remember, guys, the way in which we move, very, very important. All right. I need three statements. I need three statements that are going to make the congruency of these three triangles true. Okay. Tell me, guys. Tell me. What do we know? Anybody, you can even raise your hand. Yes, Tiana. Let's go.
Ma'am, so I have a question actually. This over angles in a converse parallel line, can't we use it as reasons here by this?
Yes, we can, because we proved it above. Yes, absolutely, we can. Okay.
Okay. Can I give reasons?
Yes, absolutely.
And then angle T2 is equal to angle R3.
Good. We don't even have to use the converse because they've given it to us. We can say given. Good. What else?
And then angle, I don't know what is it. Is it the one? Yeah, angle 1 is equal to angle T1 is equal to R4, and it's also given.
Good. Wait. Yes, R4. This was supposed to be good. It's also R4. Okay, I need one more reason for congruency, Miss Sweetie. Just one more.
Is common.
Good. TR is common, or RT. It doesn't matter. Beautiful, wonderful. Therefore, I can say that triangle ATR is congruent to triangle SRT. You know, Tiana, for somebody who keeps saying, ma'am, it's not make sure. You are very making sure. Which gives me hope. It gives me hope. You are making sure very much. All right. So we know that they're congruent. What is my reason, guys? What is my reason going to be here? Think about it, guys. I've got an angle, a side, and an angle. And then over here, I've got an angle, a side, and an angle. So what must it be? Thank you, Lesedi. Yes, I've actually just said it. Yes, I've just said it. It's angle, side, angle. Good. Good, right. Now that we know that these two triangles are congruent, we know that they're congruent. What does that tell me about the corresponding sides? What can I then say? I can say that AT is equal to what? AT is equal to, let me do it down here. AT is equal to what other side, guys? SR, good, to SR. Okay, and my reason for that, why can we then say AT is equal to SR? Because this is me going crazy. This is going crazy. Why can we then say the sides are equal to each other, guys? No, not the converse. Yeah, thank you, Tiana. Yay, yes, that's what I was hoping to hear. Because corresponding properties of congruent triangles are congruent. Because of cpctc, guys, she didn't even write it correctly. What did Tiana wrote? cptc. Girl, that's not the correct thing. That's not the correct thing. It's not even correct. It's not even in the right order, but I know what you meant. That's it, Chloe, that's it. I can then say AT is equal to SR. And then I can say that TS or ST is equal to which other side? Is equal to, ST is equal to what side, guys? That's it, to AR. For the exact same reason, ST is equal to AR. And the reason is corresponding properties of congruent triangles are congruent. Right, now look at what we have. Look at what we have. We have enough information to prove that that our rhombus is or our quadrilateral is a rhombus, okay? Therefore, STAR is a rhombus, okay? So it's all about knowing the properties, guys. It's all about knowing the properties, but we will get there, okay? It takes practice, guys. It really does take practice. I want you guys to take a quick screenshot of these last two, the last two. So you can do this one where you're proving a trapezoid, and the last one where you are proving that ABCD is a square. Over here, ABCD is an isosceles trapezoid. Go look up the properties, see how you can prove them. The thing that you will like about this one is that we've already given you the information that needs to be there. Okay, I'm going to do it one more time. Okay, CPCTC stands for corresponding properties of congruent triangles are congruent. Okay. Chloe, I'm like, Chloe, take the screenshot and go do this homework. Chloe's like, no. Chloe's like, no, ma'am, I'm done, ma'am, no. All right, okay. I want everybody to take a deep breath, breathe in and breathe out. Okay, that is as far as we're going to go with proving quadrilaterals because it does take practice. Today, we're actually going to be talking about the midpoint theorem. Up here or up and sideways to where we were? Alicia's like, girl, please behave. Behave. Okay, Tiana, you've got 3 seconds. 3, 2, 1. Okay, bye-bye. All right. Okay, we can come back at the end of the lesson to have a look. All right. So the midpoint theorem Sounds complicated, but it's not. In fact, if you were struggling with quadrilaterals, this is going to be a breath of fresh air. This is going to be a breath of fresh air. Okay, let's look at it. No, Alicia, it will be a breath of fresh air. Okay, so the midpoint theorem in words says, the line segment joining the midpoints of any two sides of a triangle, so the two sides of a triangle, okay, that midpoint, that line segment joining the midpoints is parallel to the third side and equal to half of the length of the third side. Okay, now this sounds so complicated. It sounds complicated. It's not at all. It's not. So this is what it's actually saying. What this thing is saying is if I have a triangle and my triangle is named ABC, if my triangle is named ABC, and I decide I'm going to draw a line, I'm going to draw a line DE in between the two sides, right? But I'm going to start this line at D, and I'm going to make sure that D cuts the line AB in half. It cuts it right down the middle. It's the midpoint of the two of them, right? That means that BD is going to equal to AD. They're going to be equal to each other. Then I start drawing my line across. I draw my line across to the other side. And I make sure that when I get to this other side, to the point E, that I also cut the line AC in half, right? So that AE is equal to EC. Gift, you almost had it, yes. AE is equal to EC. What this tells me is that my line DE is automatically going to be parallel to BC. Okay, it's going to be parallel to DC and BC. And on top of that, if my line DE is equal to 4 centimeters, then line BC is going to equal 8 centimeters. So they're going to be double. Okay, the longer side will be double. See, and Inganati is now having fun because it's easy, so easy. Okay, this is all we need to know, that if this side over here, if this line we have in the middle cuts both of the other sides right down the middle, then it is parallel to the third side, and the third side is then twice the size of the one that cut the middle. Okay, but we also see that if these two lines are parallel, what angles must we always think of when we think of parallel lines, guys? When we think of parallel lines, what angles are we thinking of? Fun, yes, absolutely. We're thinking of fun angles, right? So we already know that if I draw my upside down F over here, I'm going to name this 1, 2. Which two angles in this F over here are going to be equal? That's correct. Inganati, 100%. If DE is 5, then BC is 10. Yes, 100%. Okay, so I want you guys, look at this. I've drawn you the F in fun. Find me two angles that are equal to each other. Which two angles are going to be equal? Good. That's it, Offense. Excellent. Excellent. That's it. D1 and B. All right, but I'm not done. I'm not done because I can also draw my F this way. I can also draw my F this way. I'm going to name this 1 and 2. Okay, which other two angles are equal to each other then? That's it, David. Good. Good, good, good. Offense, Lesedi, 100% gift. E1 will be equal to C. Okay, but now, when we are doing this, we can't just say these things are equal. No, they're not going to tell us that they're equal. They're going to say certain things, and then we have to come to the conclusions using the midpoint theorem. We can't just say that DE and BC are parallel. No, they need to give us the information first. Okay, so let's look at a quick example. Yes, Jasmine.
So the formula will indicate the coordinates of the midpoint, isn't it?
The formula, not so much, because there's only one formula when it comes to the midpoint, and that formula is just that BC is equal to 2 times the value of DE. Okay, that's the only one. If we look at it up here, that BC will be twice the size of DE. That's the only thing.
Oh.
The rest of it is going to be in the way that we phrase it. Okay, and I'm going to show you now. Okay, so let's read the information that they've given us here. All right, my sweetie. We're going to look at the information they've given us here. It says here, the figure below shows a large triangle with vertices A, B, and D. So we've got A, B, D. That's the triangle we're looking at. And a smaller triangle with vertices D, C, and E. And then it says point C is the midpoint of BD, which automatically tells me that DC is equal to CB because it's the midpoint, right? And then it says, and point E is the midpoint of AB. So now we know that DE is going to be equal to EA. Okay, now I want you guys to note that doesn't mean that this one and this one are equal. No, 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 no. Only these two are equal, not that one. Okay, bear that in mind, guys. Only the ones on each side are equal. Okay, so those are equal. And then it says 3 angles are given. They've given us 26 and 91 and 26. Determine the value of DCE. They want us to determine the value of this. Tiana, I'm going to need you to put your hand up and ask me, what does that mean? Put it in better words for me, please, because I'm not 100% understanding. Yes, my sweetie. What do you mean? What does that mean?
Now when Mem said, I don't know what Mem said now, but I just didn't understand. What's Mem talking about us being equal?
Okay, so remember we said that C is the midpoint of this side, right? C is the midpoint of DB. You agree with me?
Yes, ma'am.
So if it cuts DB in half, if C cuts DB in half, what does that tell me about DC and CB? That they are?
They are equal.
They're equal. Good, yes, they're equal. Does this mean that DC and DE are equal though?
I think so.
No,
Maybe.
they can't. Do you know why they can't? Look at the size. Look at the size of this side and look at the size of that side. Are they the same size?
No.
No, they're not.
No.
So they're not the only sides that are equal. The only time we can say that they're equal is if they're on the same side. Do you understand? So this one and this one are on the same side, and then this one and this one are on the same side. Those two on the same side are equal. Okay.
Yes.
Got it. Excellent. All right. That's what I was getting at there. All right. Okay. So now, before we can say that angle C is equal to whatever it is, because I know you guys can see it, it's quite obvious now that we know how to use the midpoint theorem, we actually have to put it into words. Right. I'm going to then say DC is equal to CB. And my reason for this is midpoint of DB. Okay. C is midpoint of DB. And then I'm going to say the same thing about DE and EA. I'm going to go DE is equal to EA. And my reason is because E is the midpoint of DA or AD. It doesn't matter. Right. Now, because we know that these two things are equal, what can we say about CE and AB, guys? What can we conclude? That CE is what? What to AB? Are they equal? That's it, Sange. That's it, Luyanda. Okay, good. Good. That's it, Zamanzini. That they are parallel. We can say that they're parallel. And the reason we can say this is because of the midpoint theorem. Midpoint theorem. Okay. Now we know that CE is parallel to AB. What conclusion can we then make about C? We can then say that angle DCE is equal to what? How much is it equal to? Look for the F, guys. Look for the F. That's it, part 2. DCE is equal to 91 degrees. What is my reason? There's my F, guys. Why is DCE equal to 91 degrees? Because of corresponding angles. Okay. Leander, you could say that, but we're not 100% sure, hey? We can't say triangles add up to 180 if we don't know what this angle over here is. They're corresponding angles, and we can even say it again. We can say that CE is parallel to AB. Proved above. We proved it above. Okay, give me a thumbs up. How are we feeling about midpoint theorem? It's nice and easy, I feel. Yes, Akwando. Oh, I think Akwando meant to put the hand up. It's giving, you see, compared to quadrilateral, it's giving. It's so much nicer. So much nicer. That's okay, Akwando. It's on point. It's kind of fun. You know, we're back to the fun maths. The fun teacher Coco is back. Yeah. Okay. Now, remember the order in which I've written this, guys. It's going to come back. Offenses like quadrilaterals, no. Midpoint theorem, yes. Yes, of course. I know. I know, teacher knows. I know. All right, let's look at this next one over here. Okay, now I want you guys to figure this out all on your own. I'm not going to say much. Read the information that you've been given. Read this part. Read this part here. It says, the figure below shows a large triangle with vertices G, H, and K, and a smaller triangle with vertices at J, K, and L. And then it starts giving you all of that stuff. Point J is the midpoint of HK, and point L is the midpoint of GK. Now, that tells you a lot, guys. Put it into a statement for me. Let's get to the answer. Because I think we already know what J is equal to, or KJL is equal to. Okay, Jasmine, are we ready for it?
No, I do not want to answer the questions.
Okay.
I got another question.
Yes.
Are we also gonna do triangles on a Cartesian plane with the midpoint, or just the triangles?
We will do triangles on a Cartesian plane, but that will be part of analytical geometry, which is coming next. Okay.
Oh.
Mm-hmm.
All right. Thanks.
Okay, don't stress, it's coming. Yes, Tiana.
Ma'am, I also have a question. So, the state of the Cartesian plane and that, I don't know, is cast diagram.
Yes.
Did you do that? Was it in the past lessons, or we still gonna do it?
What are you doing on the Cartesian plane? What are you doing on the cast diagram?
Yo, ma'am, we're doing sine, cosine, tan, and the Pythagoras, but I checked we already did that. Now,
We did. We remember we spoke about this, and then we drew a triangle, and then we said X, Y, and R. You don't remember that we did this, Peter?
I do remember it, but the teacher make it sound hard.
Oh, your teacher makes it sound hard, Vim. No, not with me. Not with me. If you're still struggling, go back and have a look again at the videos. Okay, go forward. In fact, just fast forward through the video. Okay.
If ma'am don't believe me, ma'am can ask Tyra. Tyra knows. Mas Harrington, yo.
Sometimes the teacher we just don't understand. Okay. Oh, your teacher makes it more hard. I'm sorry, guys. I don't know what to tell you. I don't know how to help, guys. Okay. Inganati is saying, is the answer 60 degrees? Yes, but we need to work to get there because all they've given us is a triangle, Inganati. We still need to use the midpoint theorem before we get there. Okay. All right. So we need to first say that Kj is equal to JH. And the reason is because J is the midpoint. Midpoint of KH. And then we can say that KL is equal to LG because L is the midpoint of KG, right? Then with this being said, we can therefore conclude that JL is parallel to HG. And the reason for this is midpoint theorem. Okay, midpoint theorem. Right. Yo, Chimwemo and Chloe, you guys are doing the most. Okay, cool. So with that being said, what is my angle KJL going to be equal to? Yes, Jasmine.
Another question. I do not really understand today's lesson because I understand the Cartesian plane with the midpoint formula thing.
Oh, okay. What you're looking at is analytical geometry, and this is something completely different. Okay. Okay, this is something completely different to that. Okay.
So
we're not
this
there.
is spot on.
This is Euclidean geometry. Okay. And what you're talking about is analytical geometry.
Okay.
Okay, it's not the same thing. We are not doing the same thing at all at the moment. Okay, but we're doing that next week on Wednesday. Okay. Alicia, though that is flattering, I better be paid millions. That's the only way I will do it, if they pay me millions. Okay, yes, Abiyani. Hi, Abiyani.
Hi, ma'am.
How are you doing?
I'm good, thanks, and how are you?
I'm good, thank you.
Ma'am,
What's up?
I'm a little bit confused.
Okay.
When you say KJL equals to 16, is it that, I don't know how to put this, but then when the lesson started, you told us about the corresponding angles where,
Yeah.
yes, so is the 60 the one at angle H?
Yes, and it's equal to that angle there because it's in the F. Do you see the F? Do you see it? I hope it makes sense.
Okay, I think I get it. I think.
Okay. Okay, let me just ask you then, Abiyani, before you go, what will this angle here then be equal to?
Which angle?
This one here.
98.
Yes, 98 degrees. Good, because the F is now on this side. Okay.
On that other side. Oh, thank you, Mel.
All right. Okay, excellent, my sweetie. All right, guys. Okay. Well, this is part of the midpoint theorem that we're going to be doing. Mahlatsi is saying, why isn't the J or the KJL just written as J? Okay, the reason for that is because the angle J, Mahlatsi, is actually this whole angle. This whole angle is J. And we're not just looking at J, we're looking at this part of J. And J sits between K and J and L. It sits in between there. And that's why we put it there. Okay. All right. Okay. Now let's look at this question. Okay. Now, remember there were two parts. There were two different parts to the midpoint theorem. There were two different parts to the midpoint theorem. No problem, Kylie. Okay. If you want to take it down, you've got 5 seconds. 4, 3, 2, 1. Okay. All right. So the first part of the midpoint theorem told us that if these two sides are equal to each other, then these two angles are going to be parallel, but this side is also going to be what? What is it in relation to the other side? It's not even. It's not even hard because Luandile has already given me the answer. You're welcome, my sweetie. Yes, that's it, Luyanda. It's going to be double, right? So it says here, consider the triangle. There's a line crossing in the large triangle. Notice that some lines in figure are marked as equal to each other. One side of the triangle has a given length. Determine the value of x. This is so easy, guys. We can just say, we don't even have to do very much because they haven't even labeled it for us. We're just going to say x is equal to 3 as per the midpoint theorem. How was this difficult? Make this make sense. That's all. That's all that the midpoint theorem says. And it's quite nice because if you understand it now, you can still use it again in matric because it comes up in matric. Okay, let's look at this one over here. Consider the triangle in the diagram below. Okay, there is a line crossing through the triangle. Look at the information they've given us. Notice that some lines in the figure are marked as equal to each other. One side of the triangle has a given length of 6. Determine the value of x. What is the value of x? That's it. That's it, guys. X. Oh, Tiana, remember the long side is the one that's double. The shorter side is the one that's half. Yes, teacher Nels.
The number 3.
Oh, yes.
X
Yes. Sorry.
Okay.
I didn't see. Sorry. I didn't see. I don't know what was going on with me. Thank you, teacher Nels. Thank you. I missed it. Yes, Tiana. Oh, I think that's what Tiana was trying to show me.
I was confused. I was like, how can it be? But it's okay. I get it now.
Okay, sorry, that was my bad. That was my mistake. Okay, good. So in this question, x will equal 3 and for the exact same reason, for the midpoint theorem. Okay, there we go. Because of the midpoint theorem. Okay, thumbs up, thumbs down. How do we feel about the midpoint theorem? Give says, ma'am, when they ask you how you got 6, not in this case. Okay, so what we would need, a gift, and I'll just wait for everybody's thumbs up and thumbs down, is what they would need to do is they would need to label this. They would have to go A, B, C, D, E, and then we would then have to say AD is equal to DB because D is the midpoint, and then we'd say AE is equal to EC because E is the midpoint, and then we would go DE is equal to 2 times, no, other way around, DE is the small one. We would say BC is equal to 2 times DE, and then we could calculate from there. Okay, so if they had given us the names of the sides, then we would have had to go through all of that. But in this case, they didn't even bother with that because they'd already given us what we needed in order to prove for midpoint. Okay, great. Okay, that's it from my side for this evening.